Module 1, Lesson 12, from ratio tables to double number line diagrams. So we have been working on ratios, equivalent ratios. We've done a lot of work with representing them on tables. Now we're going to look at them on double number lines. Double number lines are a particularly powerful way to represent equivalent ratios because they can really help us see what happens when we're comparing two different types of units. For example, miles and hours, or cups and grams. And that's where we're headed when we start talking about rate and unit rate. So double number lines are a nice, powerful way to look at things. All right, learning targets. We are, of course, going to be writing ratios. This first learning target, making comparisons with and within wholes, part to part to whole to part, using ratio language and symbols. And, of course, we're doing equivalent ratios, which means we are on the third learning target here. Reason about comparisons, make predictions about what would happen if part of the comparison changes. Double number lines are a great way to start identifying and describing fixed relationships, these unit rates between two values that are being compared. So we're slowly marching into unit rate as we work through these lessons. All right, so 3 I can statements for today. I can create equivalent ratios using a ratio table, and then we are going to represent equivalent ratios using a double number line. So we're going to take our ratio table and we're going to put it onto a double number line, and as part of that we're going to explore how a double number line can do a little bit more for us than a table of equivalent ratios. And then we're going to use double number lines to solve ratio problems that are related to the real world. All right, exercise 1 is an in-class activity, so I will skip that. Exercise 2. The amount of sugary beverages Americans consume is a leading health concern. For a given brand of cola, a 12-ounce serving of cola contains about 40 grams of sugar. Now, something I want to point out here, we have two different kinds of units going on. We have ounces and we have grams. So we're not comparing, like yesterday we were looking at the juice concentrate in the water and we were just kind of having parts and parts. Now we have two very distinct different kinds of units that we're comparing with each other. But they're still in a ratio statement. A 12-ounce serving of cola contains about 40 grams of sugar. So we have a ratio going on here, 12 ounces to 40 grams. So go ahead and complete the ratio table using the given ratio to find some equivalent ratios. And you'll notice that there's spots to scale up and scale down. So please take a moment and complete your table. I notice I can divide by 2 and get 6, and divide by 2 and get 20. And I can multiply by 2 and get 24. And I can multiply by 2 and get 40. But I also notice that once I've scaled down to that 6 and 20, I could actually triple the 6 and get 18, and triple the 20. Oh, that should be an 80 right there. And triple the 20 and get 60. And I also notice I can scale down even further here, and I could have 2, and I could have 10. So, divide them both by 2. That would be a 3. So I could have 3 to 10, 6 to 20, 12 to 40, 18 to 60, 24 to 80. I've got a lot of different options for my equivalent ratios. So we are going to be using that information, that 12 to 40 from that last problem, to answer a new question. A 1-liter bottle of cola contains approximately 34 fluid ounces. How many grams of sugar would be in a 1-liter bottle of cola? So we have this information that for 12 ounces there are 40 grams of sugar, but a 1-liter bottle contains 34 fluid ounces, and the question is how much sugar would we be having if we were to drink that entire 1-liter bottle of cola. And got a hint here, create a table of equivalent ratios. So pause the video build your table of equivalent ratios to help you find 34. So table of equivalent ratios here. I've got my ounces of soda, got my grams of sugar. I had 6 and 20, and I could double that, 12 and 40, and I could triple it, get 18 and 60, and quadruple, 24 and 80, and I can multiply by 5 and get 30 and 100, and I can multiply by 6 and I could get 36 and 120. And right now my brain just freaked out and said, whoa, wait a minute, I've got a problem. I don't have 34 on my table. "34 ounces should be between 30 and 36, but when I was counting by the sixes, I didn't land on 34, so I don't have 34 on my table of equivalent ratios. Where would it be? Well, it would be in here someplace, but it's not there. So I can't answer this question with the information that I have on my table of equivalent ratios. So this is where the double number line comes in as being a little bit more powerful. The double number line can help us find information that is in between on our table of equivalent ratios. So if 34 ounces of cola is in between 30 and 36, then the amount of sugar would also be in about the same spot. Well, it would be in the same spot. It would be between 100 and 120. Because each of these pairs is locked together. They go together. So if 34 is here, then the amount of sugar that goes with 34 is in the same spot. So how could we figure out how many grams of sugar there are in 34 ounces of cola? Why is this not an easy question for us to answer? Well, we're not counting by anything regular here. I don't have anything that I can scale 6 up to reach 34. It's just not there. So I'm going to need another strategy. And what we're going to use here today is a double number line. So on our table, what were we counting by when we counted the cola? Well, we were counting the cola by sixes. So I could take and label my double number line 18, 24, 30, and 36. And when we were counting the sugar, we were counting by 20s. And we know that the 34 is somewhere in between there. So now what we need to do is we need to get 34 on our double number line. So when we go from 30 to 36, what are we going to count by if we want to land on 34? What do I count by? Well, I could count by ones. 31, 32, 33, 34, 35, 36. So just like on a real number line, if I counted by fives, 5, 10, 15, just because I counted by fives doesn't mean that 1, 2, 3, and 4 don't exist. Of course they exist. I just need to put them on the number line. So getting from 30 to 36, I just need to count. And the question is, what do I count by? Well, I decided to count by ones. 1, 2, 3, 4. So 31, 32, 33, 34. And what that looks like in a little more formal picture. So to get from 30 to 34, I'd count 31, 32, 33, 34, and here's 35, and here's 36. So I counted by ones all the way through. Now it's important that we recognize and we understand that when I drew those lines, I drew them through both of the number lines. They go through both number lines. Now, if you're looking really closely here, you'll see that this actually makes something like a tape diagram, something that we have worked with and are very familiar with. And so, as we go through this explanation, be thinking about what does this tape diagram tell you? All right. So the distance between 30 and 36 is 6 pieces. 1, 2, 3, 4, 5, 6. And 34 is 1, 2, 3, 4 of those. It is 4/6 of the way. So I'm doing something here with my tape diagram. I'm looking and saying, how many pieces do I have? 6. 1, 2, 3, 4, 5, 6. And 34 is 4 of those. It is 4/6 of this tape diagram. And hopefully your head is going, yep, I totally see that. All right, so we're going to file that 4/6 away, and we're going to hang on to it. So it's 6 ones, it's 4 ones. All right, here we go. So it's 4/6. All right. So if 34 is 4/6 of the way, how far do we need to go on the number line from 100 to 200? Sorry, from 100 to 120. This distance here, how much of it do we want? Well, hopefully your brain is screaming at you and saying, well, the tape diagram says we want 4/6. I want to go 4/6 of the way from 100 to 120. So if I'm going to use that information, how can I find the number? How can I find the number that is 4/6 of the way? I want to start at 100, and I want to go 4/6 of the way, and I want to stop. I don't want to go all the way. I just want to stop at 4/6 of the way, starting at 100. Well, what is the distance? How far apart are the two numbers? Well, that's like asking what is the difference? 120 minus 100 tells me that this part of the tape diagram on this number line is going to be equal to 20. But if I keep the whole 20, if I travel the whole 20, if I use the whole 20, I'm going to go from 100 to 120. And we've already established that I only want to go 4/6 of the way. I want 4/6 of the 20. So how would I find 4/6 of 20? Well, that sounds an awful lot like a multiplication problem. I'm going to get rid of some of my beautiful drawing here. 4/6 of 20. And there are a lot of different ways you can multiply this. I'm going to show you one way that I would do it. I'm going to take the 4 and break it into 2 times 2. And I'm going to keep the 20 like it is. And I'm going to take the 6 and break it into 2 times 3. So I've done a prime factorization of the 4/6. And the 2's are going to divide out. And I'm going to have 40 thirds, which is the same as 40 divided by 3. So I'm going to take 40, and I'm going to divide it by 3. Do a little division here. And I'm not going to use a decimal. I'm just going to use a fraction. This remainder here tells me I have 1 part, and the 3 tells me there are 3 parts. So I'm going to go 13 and 1/3. So I'm going to start it at 100, and I'm going to count 13 and 1/3, and I'm going to stop. So I'm starting at 100, and I'm going to add on 13 and 1/3, and that's where I stop. So in 34 ounces of cola, I have found that there are 113 and 1/3 grams of sugar. And I have done that using a double number line that I can see is very similar to a tape diagram. And yes, I had to do a little bit of math there. I say math, a little bit of computation, because all of this logical thinking is math. I had to do a little computation to help me figure out where it lands. So I find out there's 113 and 1/3 grams. Now that may have gone very quickly. You may not feel super comfortable with the fractions. Rewind the video if you need to. Go back and review some basic fraction operations if you need to. What really matters is the conceptual understanding that you can see we've taken this space and we have split it into 6 parts, and 34 is 4/6 of those. And so I need 4/6 of the difference of 100 and 120. All right, exercise 4. School cafeteria has a restriction on the amount of sugary drinks available to students. Drinks may not have more than 25 grams of sugar. Based on this restriction, what is the largest size cola in ounces the cafeteria can offer the students? Now, once again, we're working with that ratio that we had at the beginning of 6 to 20 or 12 to 40, depending on how it's scaled. And so now we're trying to figure out how many ounces can the drink be? What is the most? Well, double number lines all set up here. Number line, I'm going to start counting at 0, and I'm going to count at 6s again. So I've got 6, 12, 18, 24. I've got 20. I've got 40. Now here's something to notice about my double number line. I started out making this one looking just like the other double number line, but I'm already past the 25 that I need, and I've only used a teeny tiny section of my double number line. So what I'm going to do is I'm actually going to step back here, and I'm going to suggest to you, before you just start drawing a double number line, ask yourself, how spread out can I make it? For example, I need 25 grams of sugar. Well, if I'm going to do 25 grams of sugar, and I'm counting by 20s, I don't need a very big double number line. So I could have 20 be here, and I could have 40 be here. I can spread it way out if I need to. Here I've got 6, and here I've got 12. Another way I could do it is I could look and say, I want to actually scale this down to 3 and 10. So here's 3 and 10, and here's 3 times 2, 3 times 3 is 9, 10 times 3 is 30. So I could spread my number line out a little bit here. Use a little bit of logic and say, how close together do I really need to make this stuff? I don't need to count to 120 for the grams of sugar. And I really don't need the 40 on there now that I counted by tens. All right, so I need 25 grams of sugar. Well, I know that 25 is in between 20 and 30. Matter of fact, I know that 25 is the middle. 25 is the middle. It's halfway. 21, 22, 23, 24. There's 25, 26, 27, 28, 29. I know that 25 is the exact middle. Now, I did something on my double number line here that might make it hard for me to solve this problem. when I did my counting, I didn't draw my lines all the way. I really should, when I do my counting, make sure that my lines are going through both of my number lines, because that's what's going to help me see I've got this tape diagram going on here. So I've got my 25. I know where it is. Now I need to figure out where are the ounces that go with that. Well, I've got 6 and I've got 9, and I know that I want halfway in between those two. And I know that I've got 10 pieces because I counted by ones between 20 and 30. So the difference here, 9 minus 6, is 3. And that 3 has to be cut into 10 pieces. 3 divided by 10, or a fraction of, oh, wait a minute, that looks an awful lot like a decimal. 3/10. So each one of my little lines here is going to be 3/10. So this is 6 and 3/10, and 6 and 6/10, and 6 and 9/10, and 7 and 2/10, and 7 and 5/10. Oh. So I've just reached the line that is halfway in between. And I just found out that 7.5 ounces of cola is equal to 25 grams of sugar. So based on the restriction, the largest size cola the cafeteria can offer the students is 7.5 ounces. All right, Chantel solves 3 math problems in 4 minutes. Use the information to complete the table below. All right, tables of equivalent ratios. 3 math problems, 4 minutes. And then we double, we triple, times 2, times 3, times 4. Oh, looks like times 5, times 6, times 7, times 8, times 9, times 10. All right. All right, so I've got my table for Chantel here. She's got soccer practice on Thursday evening. She has a half hour before practice to work on her math homework and talk to her friends. She has 20 math skill work questions for homework, and she wants to complete them before talking to her friends. How many minutes will Chantel have left after completing her math homework to talk to her friends? And we're going to use a double number line to figure this out. So she's got 20 math problems, which would be somewhere in here. And we know that she needs to complete them in under 30 minutes, and we're trying to figure out how long she will get to talk to her friends. So I need to take this information, and I need to make a double number line here, and I need to figure out the connection between questions and minutes, particularly 20 questions, and how many minutes that would take. So I've got my questions, I've got my minutes, and you know, I think I'm just going to make a simple one here. I'm going to do 18 and 24 and 21 and 28 because I want the information that is between the two of them. And I need to count and get from 18 to 21, and I want to make sure I count 20 because she's got 20 problems. So 19, 20. So here's 19, here's 20. And now I need to take a look and say, okay, what minutes go with 20 problems? Well, if I look at this as a tape diagram, I've got 28 minus 24, so I've got 4. 28 minus 24. So I've got 4, and that is going to be split into 3 parts. Okay. So I've got 4 divided by 3, which gives me 1 and 1/3. So I'm counting by 1 1/3. So this is 24 plus 1 1/3, which will give me 25 1/3. So 25 1/3. And I'm going to add a third more, 1 1/3 more, 1 1/3, which will give me 26 2/3. 26 2/3. So 20 problems is going to take 26 2/3 minutes. And she had 30 minutes to work with. So if I take the 30 minutes and subtract the 26 2/3, then I can see how many minutes she will get to talk to her friends. Well, I'm going to add one more third here to my 26 2/3. Let's see. Let me do some erasing here. So I'm going to count up. So I'm starting at 26 2/3, and I want to end at 30. So I'm going to add a third, and now I'm at 27, 28, 29, 27, 28, 29, and that gets me to 30. So I'm going to count on a third, and then 27 to 28 is one more, and 28 to 29 is one more, and 29 to 30 is one more, and I'm going to find that there are 3 1/3 minutes for her to talk to her friends. All right, so 3 different ways we can represent a group of equivalent ratios. So our strategies are extending here. Well, hopefully in your brain you're thinking, okay, I could do a ratio table. That's kind of our favorite go-to thing so far. But hopefully you also thought to yourself, hey, I can do a tape diagram. Because remember, we've done tape diagrams of equivalent ratios. And then hopefully you are starting to see some power in double number lines. So these are some things for you to think about. Two things you learned about double number lines, and one thing that you would like to know more of. And here's a summary. Double number line is a representation of a ratio relationship. It uses a pair of parallel number lines. One number line is drawn above the other so that the zeros of each number line are lined up with each other. Each ratio in a ratio relationship is represented on the double number line by always plotting the first entry of the ratio on one of the number lines and plotting the second on the number line so the second is aligned. So they're locked together. So if I've got the ratio A to B, and this is the line for A and this is the line for B, if A is 1 and B is 2, those are locked together. So the pairs are paired on the lines. Important concept with double number lines. All right, so I can create equivalent ratios using a ratio table. I can represent equivalent ratios using a double number line. I can use a double number line to solve ratio problems related to the real world. I think I need to fix that statement there. It's got a little grammatical error. And learning targets, once again, we're working with ratios, writing ratios to represent real life situations. We are working with equivalent ratios using now ratio tables, tape diagrams, and double number lines. And double number lines are a step toward unit rate. So this concludes Module 1, Lesson 12. Make sure you complete your problem set. If you've got any questions, make sure you talk to your teacher.